Okay, and this time let's do a sampling distribution for a sample mean, which follows the central limit theorem. And the central limit theorem states that if we have some kind of sample that's taken and we know what the mean and the standard deviation of the population are, then the sampling distribution should have average or a mean. It'll be approximately normal with a mean equal to the mean of the sample, essentially. And the standard deviation will be equal to the standard deviation of the sample divided by the square root of the size of the sample. So, suppose we have a group of 27 students that take the SAT and that their average score is, let's say, something like 1670. Further, suppose the standard deviation of students that take the SAT is around, let's say, something like 233. What is the mean and the standard deviation of the sampling distribution? Well, according to the central limit theorem, the mean is just the mean. So, quite simply, the mean of the sampling distribution will be precisely the mean, the average. 1670. Done. The standard deviation is not quite what the standard deviation of the overall group is. So it's not quite 233. Having a larger sample makes the standard deviation become smaller, and smaller by an amount that's predicted right here, the standard deviation divided by the square root of the sample size. So that means we need to do 233 divided by the square root of the size of the sample, which is 27. So let's grab a calculator and do that out. $233 divided by, too many threes. 233 divided by the square root of the size of the sample, which was 27. So my calculator says that's about 44.8409. 44.8409. And that would be the correct answer for the standard deviation. So again, these follow the central limit theorem from the reading here, that the mean is equal to the mean and the standard deviation of the distribution by the central limit theorem of the sampling distribution will be the standard deviation divided by the square root of n. Your answers are 1,670 for this example and 44.8409 for the standard deviation. Hope this helps.